Welcome to Networks Professionals.
Welcome to this explainer. Okay, right now, as you're watching this, there is a massive, totally invisible infrastructure working in the background to multiplex your digital traffic. Today, we're demystifying network port numbers. These are the critical 16-bit integers that act as the literal traffic directors of your digital life, and they are absolutely the key to understanding exactly how our devices process simultaneous data streams without skipping a single beat. So here's a quick look at our roadmap for today. First, we'll look at handling simultaneous network connections. Then, we're defining network port numbers. Third, we'll check out the most common ports, followed by the 3 categories of ports. And finally, we'll wrap up with ports, security, and firewalls. Let's get right into it. Section 1. Handling simultaneous network connections. So here's the big question. How exactly does one IP address handle multiple simultaneous connections without total packet confusion? I mean, your device has a single IP address, right? That's its unique identifier on the local or wide area network. Yet, you're probably downloading files, querying DNS, and fetching web pages all at the exact same time. All of this data rushes toward a single IP. The fundamental problem we're looking at here is how to logically route that incoming stream of ones and zeros to the exact correct application. Section 2. Defining network port numbers. Well, the elegant answer is the port number. It's a 16-bit integer, acting as a logical endpoint that identifies specific services on a device. Think of it like this. Your IP address gets the data to your hardware, to the right building, basically. But the port number? That routes it to the specific apartment, meaning the correct application layer process. Specific services map to highly precise mathematical identifiers. For instance, routing general traffic to logical endpoint 0.5.11, or pointing secure shell access over to 0.5.12. It's an incredibly precise internal sorting system. And because these port numbers are built on 16-bit integers, the underlying math dictates their absolute limit. The numbers range from 0 all the way up to a maximum cap of 65,535 possible logical endpoints. Yeah, over 65,000 individual endpoints on your single device that data can theoretically flow in and out of. To put that into perspective, it's a completely massive scale of simultaneous communication potential just sitting there on your machine. Moving to Section 3, the most common ports. Out of those tens of thousands of possibilities, let's look at the VIPs. Each unique number acts as a dedicated fast lane for a very specific protocol. Want to transfer a file? Port 21 handles FTP. Needs secure remote access? Well, SSH defaults to port 22. When you hit send on that email, port 25 utilizes SMTP. Port 53 is absolutely vital for DNS, resolving those domain names into IPs. And if you're taking over a graphical interface via remote desktop protocol, port 3389 is your designated lane. This distinction becomes incredibly clear when we look at web traffic. On one side, we've got port 80, the traditional port for unencrypted HTTP traffic. Data sent here is essentially written on a postcard. It's totally out in the open, easily intercepted and read. On the flip side, port 443 is the home of HTTPS, strictly dedicated to encrypted traffic. It's literally the difference between sending a flimsy postcard and a locked steel briefcase. The service is exactly the same, but the port dictates the security protocol. Section 4. 3 categories of ports. To keep this massive range of numbers from devolving into total chaos, it's strictly organized into 3 distinct tiers. This structured chunking shows how traffic scales from highly regulated system services down to temporary, on-the-fly communication. At the top, we have the well-known ports, running from 0 to 1023. These are the most strictly managed, reserved exclusively for standard system-level services managed by IANA. This is where your heavy hitters, like web traffic and email, live. Then, the middle tier, registered ports, from 1024 to 491511. These are a bit more flexible, typically used by specific applications, maybe a particular video game or a custom corporate software suite. Finally, at the bottom, we have dynamic or private ports, spanning from 49152 all the way to 65,535. These are the Wild West of ports. They are used entirely for temporary, ephemeral communication. Your browser might grab one of these dynamic ports just for the few seconds it takes to load an image, and then, boom, it instantly releases it back into the pool. Finally, Section 5, ports, security, and firewalls. Let's tie this whole numerical system directly to your device's security. Ports are the essential criteria firewalls use to manage, block, or allow traffic based on specific services. You see, your firewall isn't just randomly guessing what's safe in a chaotic wall of data. It is actively monitoring these precise port numbers to enforce access control lists. If you run a web server, your firewall knows to leave port 443 open, but if it detects a brute force attempt knocking on port 22, it knows exactly which door to slam shut. Basically, the firewall uses the port number as the ultimate ID badge. So, I want to leave you with this final thought to really spark your curiosity. If ports are the absolute gateways for all of these services, literally over 65,000 potential entry points on your computer alone, how well is your firewall managing the open doors to your device right now? Understanding network ports doesn't just explain how your computer multitasks so flawlessly. It empowers you to understand exactly who or what might be knocking on your network's invisible doors. Thanks for joining me on this explainer today, and keep exploring.
Thanks for watching.